right, so 12.1 was our introduction into probability and odds. This one says the table shows the number of students in your history class. Your teacher chooses one student at random to give an oral report. What's the probability the student is a female? So before I even do numbers, what am I looking for? Female over what goes in the bottom? Total. So if I find the total, if I add up all of these, I get what? 30. So that's my total. And then the female would be both the 9th grade and the 10th grade female, which would be what? Which reduces to? 7 over 15. Good. So you can write it as 7 over 15, 7.15. Okay, either one. 7 out of 15. All that's fine. Number 2 says a bag contains 8 white marbles, 6 red marbles, and 12 blue marbles. So 8 white, 6 red, 12 blue. Find the odds against choosing a white marble. So 2 things you want to figure out here. One is odds means what?
Ratio.
The ratio, and what's different about odds and probability?
You don't use it. It's a lot.
Good. It's not the total on the bottom. It's what you want over what you don't want. And this time it says the word against. So really what we want here is everything but the white. So if I did 6 plus 12, that means 18 over 8, what I don't want. Okay, and this reduces to 9 to 4. Does that make sense? Okay, so look for things like odds over probability, because that's obviously important. It changes it. And look for things like for or against. Okay, against means that's what you don't want. Questions on any of that? Okay, so I'm going to go through the homework. These are the answers to the homework. And then we'll talk permutations. So 12 says, what are the odds against stopping on a number less than 12? So in my spinner, right, it's a 4, a 6, a 9, a 12, a 15, an 18, 21, 24, 27, and 30. That's a 4. And so less than 12 would be the 9, the 6, and the 4, which is 3 of the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 total numbers. So if I wanted it to be less than 12, then it would be 3 to 7, because this is odds. Oh, okay, but it says odds. Okay. So odds against is now the 7 to the 3. Any other questions from the homework? Okay. All right, so 12.2 is called finding probabilities using permutations. Starts with the basic counting principle. So the basic counting principle says when there are m ways to do one thing and n ways to do another thing, then there are m times n ways of doing both. So we kind of talked about this a little bit yesterday. If we said we were trying to figure out what the sample set is, and we flip a coin and we roll a dice, the coin has 2 sides, the dice has 6, we would do the 2 times the 6 to figure out what the sample space was like. So it's similar that you're finding how many ways there are of doing something. So in this one it says if you have 3 shirts and 4 pants, that means that there are 3 times 4 or 12 different possibilities of outfits. Okay? You could sit here and say this is shirt 1, shirt 2, shirt 3, and then pant 1, pant 2, pant 3, and pant 4. And I can say, okay, I can wear shirt 1 with pant 1, with pant 2, with pant 3, with pant 4. And I can wear shirt 2, pant 1, pant 2, pant 3, pant 4. And I can wear shirt 3 with pant 1, pant 2, pant 3, pant 4. And I can count them all up, which would give me 12. But obviously, the more options that you have, the faster it's going to be to multiply the 2 numbers together instead. So if I had 3 shirts and 4 pants to figure out how many different combinations I could get, I would just multiply them out. 6 flavors of ice cream, 3 flavors of cones. So I just simply multiply the 3 times the 6 to get that there would be 18 different possibilities of ice cream cone with the ice cream. Questions so far? So that's called the basic counting principle. So how many ways can you rearrange the letters in the word mouse? What could happen? So let's say I have, obviously there's 5 letters, right? There's 1, 2, 3, 4, 5 letters in the word mouse, okay? If I go to pick that first letter, how many letters are there for me to choose from? There's 5 letters to choose from the first time, right? Now let's assume one of those letters gets used. How many letters can go in that second space? 4 can go in that second space. Now assume 2 of them are used. 3, assume that 3 of them are used. There's 2 left. In that last space, there's only 1 left. So if I want to figure out how many ways I can rearrange this, I simply multiply these numbers out, okay? This is called a factorial. That's why I want to go forward, and then I'm going to come back to this because I think it's easier once you understand that, okay? But if I'm rearranging it, I can't repeat the letters. Once I use M, it is used, right? So I say that there's 5 options the first time, 4 the second time, 3, then 2, then 1. These, okay? If you're dealing with just 5 letters and you want to figure out how many different ways that you can put those 5 letters in order, you just do the factorial, okay? It's called a permutation. Okay, so go back to the example. B says, how many ways can you arrange 3 letters of the word orange? So what's your N? 6, right? There's 6 letters in the word orange. Do we agree about that? Yes. How many do I want at a time? 3. So R is 3. And it is N factorial over N minus R factorial. So this is 6 factorial over 6 minus 3 factorial, which is 6 factorial over 3 factorial, which is 6 times 5 times 4 times 3 factorial over 3 factorial. This is 30 times 4, which is 120. So these are huge standardized test questions because these are questions that if you don't know how to operate with a factorial, you could figure that out. I could take the word mouse and I could rearrange it as many times as I want until I get all the combinations, right? But you'd be spending 5 minutes on one question. Where if you know permutations and you know factorials, it's much easier to take 5 times 4 times 3 times 2 times 1. Does that make sense? So this answer here, obviously, is 20 times 3 is 60 times 2 is 120 times 1 is 120. So total coincidence that they're the same. Not every answer is going to be 120. But that's all you would need to do instead of literally sitting there and trying to write out all the different combinations of mouse 120 times. You like this? Good, 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 good. I think probability is fun for people. Yeah. Go forward and then I'm going to come back. This is called a factorial. So a factorial is a number with an exclamation mark at the end of it. How many of you have seen a factorial before? Really? Okay. So like 3 with an exclamation mark is called a factorial. And it means 3 times 2 times 1. You start at the big number and you work your way down to 1. So that n represents any number, and then I would multiply it times that, times 1 less, times 1's less, times, so if it was 10 factorial, it would be 10 times 9, times 8, times 7, times 6, times 5, times 4, times 3, times 2, times 1. Okay?
The exclamation point?
The exclamation point means factorial. Yep. And then 0 factorial is 1. So this is like something you just have to memorize because there's no way to work backwards from that. Okay? 0 factorial is not just 0, it is 1. So that's a permutation is an arrangement of objects in order of which is important. The number of permutations of n objects is given by the factorial of n. So if I had 5 objects, then the number of permutations or the number of ways it can be arranged is 5 factorial. The second part of this says the number of permutations of n objects taken r at a time, where r is less than or equal to n, is given by n factorial over n minus r factorial. So if I said we have 5 objects and I want to figure out how to take them 2 at a time. Then the 5 is my n, and the 2 is my r. So I would have 5 factorial over 5 minus 2 factorial, which is 5 factorial over 3 factorial. Correct.
What do you mean by like 2 at a time?
Like I've put 5 colored balls into a bag, and I want to know how many different combinations you can get if you can only pull out 2 balls at a time, or take 2 letters out of the word mouse at a time. How many different combinations? So the R is the number you take at a time. So if there's 30 kids in here, and I'm going to pull 5 kids to the front of the room, how many different combinations can I get if I pull 5 kids to the front of the room at a time? So the 30 is your N, and the 5 is your R.
When you're doing the math though,
So I'm going to show you how that breaks down. So I could go the long way. I could say this is 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. And I could cross these out. 1s are going to cross, 2s are going to cross, 3s are going to cross. This is simply 20. Okay? But a shortcut with these is take the higher factorial and go down to the lower factorial. So 5 factorial is 5 times 4 times 3 factorial over 3 factorial. And then these cancel, and it's still 20. Yep.
so do you leave it as 5 factorial over 3 factorial?
No, you got to get the number. You got to get 20. Yeah. So the question just came, can I leave it as 5 factorial, 3 factorial? Good question. No, you got to get to 20. The answer is 20. Okay? So I'll do that little shortcut again. So let's say I had 15 factorial over 12 factorial. I can go 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, which is not going to be fun to do. Over 12, 11, 10, 9, 8, 5, whatever, keep going. Or I could say 15 times 14 times 13 times 12 factorial over 12 factorial. And then these cancel, and you're just multiplying out 15, 14 times 13. So big numbers like this, you can use a scientific calculator. Make your life a little bit easier. Questions on that? Because now we're going to go back. So factorial means multiply that number times every number smaller than it. So if it's 7 factorial, it's 7 times 6 times 5 times 4 times 3 times 2 times 1.
So,
And then you multiply those numbers out.
all right.
Yeah?
Mm-hmm.
Okay.